Hi, this video deals with algebraic multiplication and division. There are several important rules that need to be understood. These are fundamental rules that need to be known in order to proceed to the nitty-gritty of multiplying and dividing algebraic fractions or algebraic terms. So I'm going to start with the first one. First one is as follows. X to the 3 is the same thing as x times x times x. So we're saying we're multiplying x by itself 3 times. That's what x to the 3 means. Where x is a variable which could represent any number. So x is a variable that can represent any real number. You can put it this way. X could be 1, 2, 3, 4, minus 1, minus 6, any real number. So let's have another example. What's x to the 5? X to the 5 is x times x times x times x times x. Basically 5 x's. That's what this means. So in a shortcode notation, we could say x to the n is equal to x times dot 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 x, where this is the first x, this is the second x, and this is the nth x. For instance, we have x to the 3, the first x, the second x, and the last x is the third x. We have x to the 5, the first x, this is the fifth x. 1, 2, 3, 4, 5. So that's what this nth means, depending on what n is. In this case, n is 3. In this case, n is 5. So that's what this means. So if I use real numbers, for instance, if I say 2 to the 3, you know that that means 2 times 2 times 2. If I say 5 to the 4, it means 5 times 5 times 5 times 5. Basically, there will be 4 5s. So this is saying multiply 5 by itself 4 times. Multiply 2 by itself 3 times. That's what this says. It says multiply x by itself 5 times. Multiply x by itself 3 times. So this is really simple stuff. That's the first rule. The next rule is as follows. The variable x times the variable y can be written as x, y. So if I tell you, or in other words, let's use different variables. Let's use p, q, p and q. If I say pq, where p and q are variables, this is the same thing as saying p times q. So if I tell you that z is a variable, but in this instance, in a certain instance, it has a value of 1, and w is a variable which has a value of 2. If I tell you to determine what zw is, I'm trying to say what is z times w. And given that z is 1 and w is 2, I'm trying to say 1 times 2, which is 2. So you just need to get this. This is just notation. X times y is the same thing as writing x and y next to each other. A, b, same thing as a times b, where a and b are variables. Really simple stuff. The third rule is as follows. Raising any variable to the power of 0 gives 1. So say let's x takes real number values, right? So if we take, for example, the case where x is 2, so what's 2 to the 0? The case where x is 3, and for the case where x is 66, so what's 66 to the 0? All these are equal to 1 because any number or variable raised to the power of 0 is 1. That's what this rule says. The next rule is as follows. Any variable or number raised to the power of 1 is that variable. So when you raise a variable or number to the power of 1, it remains unchanged. 2 to the 1 is what? What's 3 to the 1? What's 4 to the 1? 2 to the 1 is 2. When you raise a number or variable to the power of 1, it remains unchanged. 3 to the 1 is 3. 4 to the 1 is 4. 66 to the 1 is 66. 95 to the 1 is 95. 88.95 raised to the power of 1 is 88.95. So the bottom line is when you raise any variable or number to the power of 1, it remains unchanged. Very important rule. The next important rule is as follows. Any variable or number can be written as a fraction just by dividing it by 1, because dividing any number or any variable by 1 doesn't change anything. So for instance, let's write it the other way as well. Any variable divided by 1 is itself. 2 is the same thing as 2 over 1. 3 is the same thing as 3 over 1. 99 over 1 is the same thing as 99. Dividing by 1 doesn't change anything. The next rule might appear confusing at first, but we have to take our time, but it's very easy to understand. So the variable a multiplied by the variable x divided by the variable by gives this expression. This is a fraction. The numerator is ax, which is the same thing as a times x. The denominator is by, which is the same thing as b times y. Remember that x times y can be written as xy. So just remember that. So now this fraction can be written in so many forms because we have the following: a times x over b times y. This can be written as a over b times x over y. It can also be written as a x over b times 1 over y, or as a over y times x over b, or as a over 1 times x over by, and so on. There's so many other ways you can write it. But how did I get from this expression, or even this expression, to these expressions? Because what I'm saying is this fraction, ax over by, can be written as two separate fractions as follows. It can be written as a product of two separate fractions in so many ways. There's so many other examples. But how do you get from here to these different forms? Well, I'll show you. Now, starting with ax over by, here's the technique. Ax is the same thing as a times x, so here's our numerator. The denominator, by, is the same thing as b times y. Now here's what you can do. You can pick a numerator and any denominator and form a fraction. So you can say I form a fraction with this numerator and this denominator term. And you can also say I can pick this numerator term and this denominator term and form another fraction. And you can express this term as a product of the two fractions we formed. So our first fraction is a over b. Our second fraction is x over y. So that's one way. Just even going back, still writing ax over by as a times x over b times y. We can also pick the fractions in different ways. I can pick a as my numerator term and y as a denominator term, form a fraction with it. I can also pick x as a numerator term and b as another denominator term and form a fraction with it. And I can get my first fraction, a over y, times x over b. Again, rewriting ax over by as a times x over b times y. I can even say let ax be my numerator term, a times x, and just y be the denominator for this fraction, and let b be the only denominator, and I can just put a 1 and say let a 1 be the numerator term, and that gives me 1 over b times a times x over y. And if you don't believe, if I simplify this product, I get a times x, which is ax, over b times y, which is by. Because when you're multiplying fractions, you multiply numerators by themselves and denominators by themselves. Similarly here, a times x, ax, y times b, yb, which is ax over by, because y times b is the same thing as b times y. Just note that. Also here, I have 1 times a times x, ax, 1 times ax over b times y, which is ax over by. So you can break down any fraction like this, any fraction which has a product of two variables as a numerator and a product of variables as a denominator, as follows. It's really simple. And we'll do another example. So say we have the fraction pq over WZ. PQ is P times Q. WZ is W times Z. So I can form my first fraction with P as the numerator and Z as the denominator. I can form a second fraction with Q as the numerator and W as the denominator. And this gives my first fraction, P over Z, times second fraction, Q over W. So what I'm saying is, any fraction of this form can be broken down into a product of two fractions, or even more, but we're just focusing on breaking this into two fractions. I'll do another one. So PQ is P times Q. The denominator WZ is W times Z. I can form a fraction using P as a numerator term and W as a denominator term. I can form another fraction using Q as a numerator term and Z as a denominator term. I can simplify it to give the product of two fractions, P over W as my first fraction and Q over Z as my second fraction. Again, if you simplify this, you get PQ over ZW, which is the same thing as PQ over WZ, because ZW is Z times W, which is the same thing as W times Z. Again, PQ, P times Q is PQ, W times Z is WZ. And you can see that this is the same as the original fraction. Same here. This term is the same as the original fraction. Here's one more example. So starting from here again, PQ is written as P times Q, WZ is W times Z. I want to express this term, which is now this term, as a product of two fractions. I can form one fraction by combining these two numerator terms to give my numerator term and just Z as the denominator, and I can write that fraction out as P times Q, which is PQ over Z. And my other fraction could be, I'll just place a 1 here, because 1 times anything doesn't change it, and my second fraction would be 1, we'll have 1 as a numerator and W as a denominator, and this gives me 1 over W. Simplifying this gives PQ times 1, which is PQ, Z times W is ZW, PQ over WZ, because Z times W is the same thing as W times Z. And that's pretty much it. So it's just a case of breaking it down as it has been shown. So feel free to review this video till it sticks, because it may be a confusing concept if this is the first time you're seeing it. Here's the same concept, but this time I'm going to use numbers. So 2 times 3 over 5 times 6 can be broken down into two fractions. Here's one fraction. I just pick a numerator term and a denominator term and I form a fraction. Here's another fraction. I pick a numerator term and a denominator term. And this gives 2 over 5, first fraction, times 3 over 6, second fraction. Doing so gives 2 times 3 over 5 times 6, which is the same as the original fraction. We can try again with 2 times 3 over 5 times 6. We can form another fraction. Let's pick 2 as a numerator term and 6 as a denominator term. You can also pick 3 as a numerator term and 5 as the other denominator term for the other fraction. This gives us a product of two fractions as follows, which when you simplify, numerator times numerator term, 2 times 3, denominator times denominator, 6 times 5, which is what we started with in the first place, because 6 times 5 is the same thing as 5 times 6. So I believe you get it now, but the more confusing one is when I pick two terms as the numerator term for the new fraction. So again, with 2 times 3 over 5 times 6, I can form my first fraction with 2 and 2 times 3 as the numerator term and 6 as the denominator term of one fraction, and I can place a 1 here or even a 1 here and say, well, this is the numerator term of my second fraction, that's 5 is the denominator term of my second fraction, and this would give the first fraction as 2 times 3 over 6, this first fraction in red, and the second fraction as 1 over 5, and this is the same thing as 2 times 3 over 6 times 5, same thing as 2 times 3 over 5 times 6. So you should get used to this way of breaking down fractions. It's going to prove useful shortly, so feel free to review this video as many times as you need. Now we're going to focus on 3 important laws of indices which come in particularly handy when dealing with multiplication problems, algebraic multiplication problems to be exact. Here's the first one. First one here is saying x to the n times x to the m is equal to x to the n plus m. For example, 2 to the 3 times 2 to the 4 is equal to 2 to the 3 plus 4. Now here x is a base and it's being raised to a power. X here is also a base and it's being raised to a power. So here the base is x and it's being raised to the power of n. Here the base is also x and it's being raised to the power of n. So what this rule says is when you're multiplying two terms with the same base, where they're raised to certain powers, the result is the same base raised to the sum of the powers. X to the n times x to the m is equal to x, the same base, to the power of n plus m. Let's do another one. 3 to the 4 times 3 to the 2 is equal to 3 into 4 plus 2. Here, these two terms have the same base, so the result is the same base. And since you're multiplying them, you sum the powers. So it's just a simple case of obeying this rule, really. I need not say more like this, really. This rule is self-explanatory. The next important law is this, which says x times y, all raised to the n, is equal to x to the n times y to the n. X times y to the n is equal to x to the n times y to the n. And the variables are not just restricted to x and y. It could have been the variables p and q. P times q raised to the n, for instance, is equal to p to the n times q to the n, which is p n q n. So that's what this rule is saying. Simple rule. So for example, if you have 2 times 3 to the power of n, so let's say to the power of 2. Now naturally, if you wanted to do this, you'll say 2 times 3 is 6. So this raised to the power of 2, 6 to the 2 is 36. But using this law, this particular law, you can rewrite this as, so let's start again, 2 times 3 to the 2. You can say, well, that's 2 to the 2 times 3 to the 2. What's 2 to the 2? That's 4. 3 to the power of 2 is 9. So 2 squared is 4, 3 squared is 9. 4 times 9 is 36. So this rule works, and you need to remember it. Please review it as long as it takes, as long as you can recall it without even exerting yourself much. The next law says x to the m, all raised to the power of n, is equal to x to the m times n, or x to the m times n. So here's an example. 2 to the 3 raised to the power of 4 is equal to 2 to the 3 times 4, to the power of 3 times 4. That's what this rule says, which is 2 to the power of 3 times 4, 12. That's what this rule says. So just to take a step back, the law says x to the m raised to the power of n is equal to x to the m times n, where x is a variable, m and n real numbers. For the case where x is 2, or rather, for the case where we have 3 to the 4 all raised to the power of 4, comparing this to this expression shows that x is 3, the base in this inside the bracket is 3, m is 4, and n, the term outside, is 4 as well. So this 3 to the 4 to the 4 must be equal to x, which in our case is 3, to the power of m times n. M times n, 4 times 4, which is equal to 3 to the power of 4 times 4, 16. So these rules are really easy to use. So this is the first one. X to the m, all raised to the n, is equal to x to the power of m times n. X, y, all raised to the n, is equal to x to the n times y to the n. And just to rewrite this, x to the n times x to the m. So multiplying two variables which have the same base with different powers or the same power, so we don't really care about that, but the key thing is they have the same base. When you multiply two variables raised to whatever powers with the same base, the result has the same base, but you sum the powers. So please review these rules and remember them. They're as important to maths as the alphabet are important to the English language. Thank you. Now we're going to go through a few example problems, and it'd be a good idea to revise all the rules and laws we've learned so far. So if you feel like you need to rewind and go to the previous laws and rules, please do so that you can follow the examples and understand the application of those rules and laws. So we're going to go through a few examples. So here's one. Simplify a times x. Well, this is simply ax because if you remember the rule, xy is equal to x times y, and vice versa, x times y is xy. So the product of two variables can just be expressed by placing them next to each other as follows: a times x is ax. Very simple problem. Here's another one: a times x squared. What is this? Well, it's simply the same thing. We have the variable x, and you have this whole variable x squared. So you do the same thing, you just place them next to each other, and this simply means a times x squared. Same rule being applied. Here's another example. X, y, all raised to the power of 2. Well, this simply comes from the rule xy to the n is equal to x to the n times y to the n. In this case, our n is 2, so we have x to the 2 times y to the 2, just by using this rule. So it's easy so far, as you can see. Let's try another example. X raised to the power of 3 times y raised to the power of 5. Using the same rule we've used previously, x, y equals x times y. This gives us x to the 3 times y to the 5. You just place them by each other. This can be read as x to the 3 times y to the 5. Has another example. So let's try x cubed times x squared. Well, this can be simplified. You could say this is x cubed x squared. You could say so. But if you remember that there's a rule that says when you have a product of the form x to the n times x to the m, it can be simplified as simply written as x to the n plus m. Same bases, same base. And then you sum the powers. So in this case, our n is 3 and m is 2. So this expression is x to the n plus m, 3 plus 2, which is equal to x to the 5. Here are a few more examples. So we have this x times x to the 7. As you remember, x is the same thing as x to the 1, so I can write this as x to the 1 times x to the 7. And we know that x to the n times x to the m is x to the n plus m. So x to the 1 times x to the 7 is x to the 1 plus 7, which is x to the 8. Next one, x to the 100, all raised to the power of 5. Well, if you recall, x to the m, all raised to the power of x to the n, is equal to x to the m times n. Therefore, x to the 100 all raised to the 5 is x to the 100 times 5, which is x to the power of 500. Here's another example. X cubed y times x cubed y times x squared. To solve this problem, I'm going to break x cubed y to x cubed times y, and we have times x cubed. So this x cubed y is this. We have our times, and we have our x squared. So now, how do we proceed? Well, I can rearrange this multiplication problem because in maths, when you're multiplying any number of terms, the order in which you carry out the multiplication doesn't matter. So a times b times c is the same thing as a times c times b, which is the same thing as b times a times c, and so on. The order in which you carry out the multiplication doesn't matter. So x cubed times y times x squared can be written as x cubed times x squared times y. I can rearrange the order in which I carry out the multiplication. Now, If I just consider x cubed times x squared, I can simplify to give x raised to the power of 3 plus 2 using this rule here. Apologies. This rule here. And I still have my times y. And this gives me x to the 5 times y, which is x to the 5y. Dropping the multiplication sign. So as you can see, this complex looking problem really has a simple solution. You just have to use two different laws in this case. Here's the next example. So we have y to the 5 divided by 5 times y squared. Now if you remember, a is the same thing as a over 1. B over 1 is the same thing as b. So you can rewrite this problem as y to the 5 divided by 5 times, instead of y squared over 1. So that we have two fractions, which can easily be multiplied. When multiplying fractions, you multiply the numerators by each other, and you multiply the denominators by each other to give a resultant fraction, whose numerator is the product of the numerators of the original fractions, and whose denominator is the product of the denominators of the original fraction. In this case, we get y to the 5 times y squared as our numerator, and 5 times 1 as our denominator. Now, if you recall, x to the m times x to the n is x to the m plus n. This also applies for any other variable like y. Y to the m times y to the n, same thing as y to the m plus n. So y to the 5 times y to the 2, same thing as y to the 5 plus 2. All divided by 5 times 1, which is 5. So this gives us y to the 7, all divided by 5. Let's take a look at two more examples. So we've just been simplifying expressions, so now we just need to simplify this expression and this expression, and we're done. Now this expression can be written as 3y over 4 times, instead of x squared y, we can say x squared y over 1, just to represent it as a fraction, so that we can easily multiply these fractions by each other. And you know that when you're multiplying fractions, the resulting answer is a fraction whose numerator is the product of the numerators of the original fraction. So it's 3y times x squared y, and the denominator is the product of the denominators of the original fraction, so 4 times 1. And this can be broken down as 3y times x squared times y. X squared y is the same thing as x squared times y over 4 times 1, which is 4. Now rearranging the order in the multiplication as 3y times y times x squared over 4 is allowed. All I've done is just rearrange the multiplication order. So you remember, a times b times c is equal to a times c times b, which is equal to b times c times a. The order doesn't matter when it's just multiplication. But the reason I did that was to bring the like terms together, to bring the terms involving y together, so I can easily simplify. So now we have 3y times y is what? 3y squared. Or if you can't see it, we have 3y as 3 times y times x squared over 4. So 3y is now 3 times y times y times y times x squared. Now y times y is the same thing as y to the 1 times y to the 1, which is y to the 1 plus 1, which is 2, times x squared over 4, which gives 3y squared x squared, all divided by 4. Now in case you missed what I was saying here, I'm saying y times y is same thing as y to the 1 times y to the 1. And recall, y to the m times y to the n is equal to y to the m plus n. So y to the 1 times y to the 1 is equal to y to the 1 plus 1, which is y to the 2. And that's what I've done here. Y to the 1 times y to the 1 is y to the 2. So 3 times y squared times x squared, just drop the product sign, since the multiplication, 3y squared x squared over 4. And that's it for that example. Finally, let's look at the last problem, which is actually the easiest of all the ones we've done today. So we want to simplify this expression, y times x plus 1. Remember that when you're multiplying two variables, you can rewrite them by just placing them side by side, or just by ignoring the product sign and just writing the terms side by side. In this case, you can treat y as a variable and this whole bracketed term x plus 1 as a variable. So this term can be simplified as follows. I just drop the multiplication sign.